In this video, I'm going to go over the warm-up that we did and give you an opportunity to hopefully learn from some of the mistakes that you made. You may have forgotten some of your algebra, and hopefully this will help to refresh your skills. So if you look at number 1, I could write this as minus x, and let's say x was 3. So if x were a positive number like 3, this would be a true statement. That is a negative number. It's the number negative 3. But what if instead x had been negative 3? Then you'd have negative 3, which actually would be positive. So this statement is not always true. It's only true when x is a positive number. And so for that reason, we would say that this is a false statement. Now in number 2, this is false. You can't square the x and the 3 separately. Some people get this confused with a problem like this, where there is a rule of exponents that says we can square the 3 and the x separately. So here we would get 9x squared. But there's no property for a problem like this where you have addition or subtraction. You have two terms here. So there is no rule of exponents for this. The only thing I can do is multiply 2x plus 3's. Now when you do that, you've got a FOIL. Multiply your first terms, you get x squared. Multiply your outer terms, you get 3x. Multiply the inner terms, you get 3x. And multiply the last terms, you get 9. So you end up with x squared plus 9x. Wait a second, not 9x. How about 6x plus 9? And so this is also false. If you look at number 3, in order to solve this equation, you would have to divide both sides by negative 3. We're trying to get x by itself. Negative 3 divided by negative 3 is just going to be 1, and you're left with x. And the other side we have negative 4/3, so it looks like this would be true. But this is an inequality, and one of the things we learn about inequalities in algebra is that if we divide both sides by a negative, we have to reverse the symbol. And so the answer here is actually x is greater than negative 4/3. All right, let's go ahead and look at number 4. If you're trying to graph this, let's see, 1, 2, 3, 4. We would have a point right there. The thing is, every point on this line has a y value of negative 4. And so this is a horizontal line. So this one was true. Sorry, I didn't write false on the last one. So we have false, 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 true so far. On number 5, this is in the form y equals mx plus b, slope-intercept form. M stands for slope, and our y-intercept is 0, comma b. So that's why we call this slope-intercept form. It gives us the slope and the y-intercept. And in fact, the slope here is actually negative 3. So this is backwards. The y-intercept would actually be the 0.04. So this is also false. Now look at number 6. The 5 becomes a minus 5. The minus y becomes a plus y. On the other side, the minus 7 becomes a 7. So what happened here is all my terms change signs. And in fact, that's exactly what happens when you multiply this first equation by negative 1 on both sides. Every term changes signs. Or you could think of it as division by negative 1 on both sides. Either way, every term will change signs. And so that is a true statement. All right, let's go on. I want to mention one thing here. I put these problems here because these are some basic things we do in algebra, but they're things that students get confused. And so hopefully I've helped you to kind of remind you of some things that you may have forgotten or gotten confused. All right, let's look at number 7. Now if I were doing number 7, I would make a shell. So wherever you see an X, I'm going to put parentheses. And then I'm going to plug in my X value, which in this case is -2. And then at this point, I'm just using the order of operations to simplify this. So -2 squared means multiply 2 -2's. That's going to be 4. Now we have a -3 times a -2. This is going to be +6. And so you should have gotten 10 here. On number 8, when we add or subtract fractions, we need a common denominator. So we need to look at our multiples of 12 and our multiples of 8. Notice 24 is what we call the least common multiple. It's going to be the least common denominator for our new fractions. We need to rewrite these fractions so that they both have a denominator of 24. So we had to multiply by 2 here to get that 12 to become a 24. So we're going to multiply the numerator by 2 and we get 22. Notice that 22 over 24 is the same as 11/12. I've just reduced by dividing the numerator and denominator by 2. We called this building fractions. Basically, I multiplied 11 over 12 by 2 over 2. And that's legal because 2 over 2 is just 1. And when you multiply by 1, that doesn't change the value. We're just rewriting the fraction in a different form. All right, so on the other one, we need 24, so we're going to have to multiply by 3. So we'll multiply the numerator by 3, and so we're going to get 9 over 24. 22 minus 9 is 13, and so we get 13 over 24. On number 9, notice this is a -1. We didn't have a number there. We can just put in a 1. We're really just distributing a -1 here. We have 5x minus 1 times 11. That's a -11x, which we write as minus 11x. And -1 times a +3 is -3. We write that as -3. And so the 5x and the minus 11x can be written as a -6x. We get -6x minus 3, and so that's D. Now number 10, well, let's see, we want to get x by itself, so let's get rid of that 3 first. We're going to get 2 is equal to -4x. Let me move this up here. Now to get x by itself, we got to divide by -4. And so we're going to end up with x equals -1/2. So that's letter D. All right, let's move on. Number 11, we're trying to solve for y. What we're really doing is rearranging this equation so that it's solved for y. Right now it's not solved for any letter. And we do this because sometimes we want our equations to be in a different form. Like if I was trying to graph this line, it would be easier if this line were in slope-intercept form, and I'd want to solve for y. So let's go ahead and do that. First of all, we need to get rid of the 3x term. We're going to be left with -2y on the right, or I'm sorry, on the left. On the other side, I'm going to go ahead and put the -3x first, and then the +8. Notice we can't add those because they're not like terms. One's got an x and one doesn't. And then we're going to divide everything by -2. So we end up with y equals, now we can break this into 2, -3x over -2 plus 8 over -2. This becomes y equals, a negative divided by a negative is a positive. So 3/2 x minus 8 over -2 is -4, and we'll write that as -4. So that one would be the first one, letter A. On number 12, we're doing a similar thing. We're trying to solve for lowercase a. So the first thing I want to do is clear the fractions in a problem like this. So I'm going to multiply each side by 4. Now when I do that, let's see, on the left, I'm just going to have 4a. On the right, these 4's are going to cancel. You could put a 1 here if you want. And 1 times a plus b is just a plus b. And so we're almost there. I need to get rid of this b. So let me do that, because I'm trying to get a by itself. And so we're going to end up with 4a minus b is equal to little a. And if you want, you could change the order, put the a on the other side. In any case, your answer is B. All right, let's move on. It says find the x-intercept. So let me go ahead and rewrite this equation right here. To find an x-intercept, we want to let y be 0. So basically, I'm going to let y be 0, and I'm going to solve this for x. So that's how we find an x-intercept. We let y be 0. If we were finding a y-intercept, we would let x be 0. So we're going to end up with 8x is equal to negative 40, because 5 times 0 is just 0. 0 plus 8x is 8x. So we're going to get negative 5 here. So the correct answer is negative 5 comma 0, which is answer B. On number 14, this is all multiplication. And so I can multiply my numbers, negative 10 and 4. That's the nice thing about multiplication, is you can multiply in whatever order you want. So I want to multiply my numbers first. Negative 10 times 4 is negative 40. And hold on a second, I'm going to go backwards here. So I multiply my numbers first, I get negative 40. I'm going to multiply my x to the 5th times my x squared. So basically this is 5x's multiplied here. This is 2x's multiplied here. That's a total of 7. All we do, the shortcut, is just add the exponents. Similarly, y cubed times y to the 5th, we're going to get y to the 8th. And so the answer, whoops, I added wrong. This was 7. All right, so that would be letter B. All right, number 15. Each input has exactly one output. Such a relation is called a function. And we'll talk a lot about functions in this course. On number 16 there, the way we simplify this, we actually did this earlier when we were solving for y. We want to break this into two fractions, 4x over 4 plus 8 over 4. And so 4 over 4, that's 1. We're going to end up with x plus 2. The thing that students will sometimes do is try to cancel these 4's, or maybe cancel the 4 with the 8 and put a 2 there. But you can only do canceling when you have all multiplication. So if I had like 32x over, or we'll just say over 8, I could divide the 32 by 8 and get 4, and divide the 8 by 8 and get 1. So I can only do this kind of canceling thing when it's all multiplication. In the numerator, we have 32 times x, whereas in number 16, we have terms in the numerator. So you cannot cancel a term or part of a term. So the only way to simplify number 16 is the way I did it earlier. All right, let's move on. Now, number 17, the first thing I would do is simplify everything I could on each side. So I can distribute on the left, I get 2x minus 10. And then let's bring down the 8. Notice the 8 is not in the parentheses, so we don't distribute the 2 times the 8. And then on the other side we have a 3x, and then it's minus 4 times each of these. We'll have to distribute negative 4. Negative 4 times 2x is negative 8x. A negative 4 times a positive 3 is negative 12. And so let's see, we got some more work to do. We can combine the negative 10 and 8. We're going to get 2x minus 2. On the other side, a 3x and a minus 8x is a negative 5x, and we have minus 12 there. So we simplified everything that we could on both sides. Now at this point I'm looking at this equation and I see an x on both sides. So let's get rid of it on one side. I'm going to get rid of it on the right, because my goal is to get x by itself on one side. I can't have x on both sides. We get 7x minus 2 equals negative 12. This is what I call a two-step equation. It's going to take 2 steps to get x by itself. So the first thing we would want to do here is add 2 to both sides. We're going to get 7x is equal to negative 10. And then we have 7 times x, so to get rid of that 7, we'll have to do the opposite and divide. And we get x is equal, oops, that should be positive there, negative 10/7. So if you just take it step by step, I think that's the key there. Number 18, we did this earlier. We just need to FOIL this. It's a binomial times a binomial. We multiply the first terms, we get 7a squared. The outer terms, that's going to be 14a. The inner terms, negative 5 times a, we're going to get a minus 5a. And the last terms, negative 5 times 2, we'll get a minus 10. We've got a couple of like terms here. 14 minus 5 is 9. And so we get 7a squared plus 9a minus 10. This is what usually happens when we FOIL. We end up with a trinomial which has 3 terms. All right, let's go to the last 2 problems here, although 19 has 2 problems in it. On number 19, you need to remember something. Let's say you had x plus 5 times x minus 5. In a case like this where we have the same numbers, x and 5, in both binomials, the only thing different is one has a positive and one has a negative, or a plus and one has a minus. What you find when you multiply these types of binomials, when we FOIL, what's always going to happen is our middle 2 terms, our inner and outer products, are going to be opposites. And so we end up with x squared minus 25. Now x squared is x times itself, or x squared, and 25 is 5 times itself, or 5 squared. And so this is what we call a difference of squares. And so that's what we have in number 19 here. And what we know is, when we see that pattern, is x squared we get by multiplying 2 x's together. And 16, we ask ourselves, what times itself is 16? That would be 4. And one's going to be a minus and one's going to be a plus. And if you FOIL that out, you can verify that that does work. Now part B, the first thing you should notice is that all these terms have negative numbers, and so 2 is a common factor. And in fact, x is a common factor. The first term has x cubed, so 3 factors of x. The second term has 2, and the third has 1 factor of x. They all have at least 1, and so that's my GCF, 2x. And then since there's 3 terms, I'll have 3 terms here. And actually, you know, let me do something here. I want to make this a little bit better. So 2x times something is going to be 2x cubed. I need an x squared. And 2x times something is 6x squared. That would be 3x. and 2x times something gives you negative 8x, that would just be minus 4. Now, one of the ways to get these numbers inside the parentheses, if you're not seeing what I did there, is just divide each of these by your GCF, 2x. So notice 2x cubed over 2x, the 2's cancel, and x cubed over x to the first, we subtract the exponents, we get x squared. Or look at the last one, a minus 8x over 2x, the x's cancel, negative 8 over 2, you get a minus 4. Now the other thing that's going on here is we have a trinomial here that can be factored using a technique you may have learned previously. It's going to be the way we're going to be doing it. It's called the split B method or the AC method. So basically how this works is this trinomial is of the form ax squared plus bx plus c. So notice in our problem, a is 1, b is 3, and c is 4. So what we need to do is find two numbers that multiply to ac. Well, a is 1 and c is negative 4. So in this case, ac would be 1 times negative 4, which is negative 4. And so we need two numbers that multiply to negative 4. This is my AC. And that add up to B, which is 3. And so let's see. How about 1 times 4? And we need the 1 to be negative. And then negative 1 plus 4 would add up to the 3. So we're going to go ahead and split our b term. We get x squared plus 3x minus 4 becomes x squared minus x plus 4x minus 4. And then we factor by grouping. We can group the first two terms here, and we get x times x minus 1. And if we factor out a 4, let's see, I need an x, I'll get x minus 1 here. This has to be a positive 4. We end up with x minus 1 times x plus 4. So the final answer, don't forget we had a 2x here, is going to be 2x times x minus 1 times x plus 4. Now I went through that kind of quickly, but this is stuff that I'm reviewing, stuff that I'm assuming you've learned before. If you're rusty, I would encourage you to watch the videos on factoring that go into a lot more detail. Alright, so on number 20, if you're trying to solve for x, the first thing you want to do is get 7 on the other side. So I would subtract 7 on both sides, and I would get that. And I'm not going to factor this. I'm going to factor it, but I'm not going to show you the work. You would use the AC method, which is what we were just doing in the last problem. Let's see, this would be 3x and 2x, and 7 and 1, and let's see, minus and plus, so that should do it. Alright, so once you factor that using the AC method, you want to set each of your factors equal to 0. And then we can solve here by adding 7 to both sides and then dividing by 3. Whoops. And so you get 7/3. If you solve this side, you'll get negative 1/2. Now, if you tried the other one, it doesn't factor. You'd actually have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So it'd be, in this case, a is 1, b is 3, and c is 5. And so you'd have negative 3 plus or minus the square root of 3 squared minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. So we're going to have negative 3 plus or minus. So this is 9 minus 20. So 9 minus 20, that's actually negative 11. And so anytime we have the square root of a negative, this is an imaginary number. And we'll go into this later on, but you can actually pull out an I, and you get negative 3 plus or minus I times the square root of 11 over 2. All right, and that is it. I hope that was helpful.